In this screencast, we introduce the idea of unit conversion. Suppose you calculate a certain distance to be 24,700 feet. Given that this is such a large distance, a better unit of measurement is probably miles. So we would like to express 24,700 feet in terms of miles. In this section, we discuss how unit conversions like this are performed. The central idea in unit conversion is to multiply the given quantity by a conversion factor that relates the given units and the desired units. A conversion factor is a fraction whose numerator and denominator are equivalent to each other. Here are some examples of conversion factors. 12 months is equivalent to 1 year. In other words, there are 12 months in a year. This fraction right here has equivalent numerator and denominator, so we would call it a conversion factor. Similarly, there are 10 to the 6 watts in 1 megawatt, so these are equivalent. So this is a conversion factor as well. Here, there are 5,280 feet in 1 mile, so these two measurements are equivalent. There are 1,000 grams in 1 kilogram, because remember, kilo means 1,000. So again, the numerator and denominator are equivalent to each other. One final note. Notice that the reciprocals of each of these fractions would also be conversion factors. So if I wrote the reciprocal of this fraction, for example, that would give me 1 year in the numerator and 12 months in the denominator. Again, the numerator and denominator are equivalent, so that too would be a conversion factor. The reciprocals of all of these fractions would be conversion factors. Let's practice determining conversion factors in the next example. In this example, for parts A, B, and C, determine 2 conversion factors, including the reciprocals, that relate each of the following pairs of units. So let's start by looking at A. We want a conversion factor that relates feet and inches. In order to find a conversion factor relating feet and inches, we ask the question, how many inches are there in a foot? We know that there are 12 inches in a foot, and our conversion factor would have to express that fact. So one way of writing the conversion factor is to say that we have 12 inches per 1 foot, written in fraction form this way, so the numerator and denominator are equivalent. And I can also write the reciprocal, 1 foot per 12 inches. Now let's go ahead and look at a conversion factor relating quarts and gallons. So we ask the question, how many quarts are in a gallon? You may or may not know this, but there are 4 quarts in 1 gallon. So a conversion factor relating quarts and gallons would express this fact. So we could say, for example, that there are 4 quarts per 1 gallon, or we could write the reciprocal, that there's 1 gallon for every 4 quarts. Now let's look at a conversion factor that would relate megabytes and bytes. To do this, you need to recall that the prefix mega means to multiply by 10 to the 6. So 1 megabyte is the same as 10 to the 6 bytes. So we get our conversion factor from knowing that. There are 10 to the 6 bytes per 1 megabyte. We could also write the reciprocal. 1 megabyte per 10 to the 6 bytes. So calculating conversion factors boils down to just knowing how many inches, for example, are in a foot, how many quarts, for example, are in a gallon, how many bytes, for example, are in a megabyte. You always have to ask that question when you're trying to determine a conversion factor. Sometimes conversion factors are obtained from multiplying two or more known conversion factors so that the product has the desired units in the numerator and denominator. Suppose, for example, that you wanted to find a conversion factor relating seconds and years. So, like we did in our example above, we would start by asking, well, how many seconds are there in a year? I'm guessing most of us don't know the answer to that question, so we're going to need to break this problem down into smaller steps. We know, for example, that there are 60 seconds in a minute, so there's a conversion factor relating seconds and minutes. We know there are 60 minutes in an hour. We know that there are 24 hours in a day, and we know that there are 365 days in a year. Each of these fractions is a conversion factor relating the units that are in the numerator and denominator. So we should be able to use these 4 conversion factors to help us find a conversion factor that relates seconds and years. Notice what happens when we multiply these 4 conversion factors. To multiply these 4 fractions, we multiply the numerators, the 4 numerical values there, that would give us this product, and we multiply the denominators, which means we multiply all of the 1s, which gives us a product of 1 in the denominator. We also treat the units the same way we treated the numerical values. In the numerator, we're multiplying seconds by minutes, by hours, by days. In the denominator, we're multiplying minutes, hours, days, and year. And so you see these respective products right here. When we multiply the numerical values, we arrive at 3.1536 times 10 to the 7. Now let's look at what happens with the units. If we treat the units the same way we treat other numerical factors, then we should be able to do some unit canceling here. Notice, for example, that minutes occurs in both the numerator and the denominator. And these are factors. These units are just like numerical factors. When numerical factors are common to the numerator and denominator, we cancel them. Similarly, we can cancel the minutes. Hours also appears in both the numerator and the denominator. We can think of them as common factors that are eligible for canceling. The same thing also happens with days. Days occurs in both the numerator and the denominator and therefore should be eligible for canceling. This leaves us with seconds in the numerator and year in the denominator. which is why you're seeing them right here. So notice we arrive at a fraction that has seconds in the numerator, years in the denominator. Therefore, this should be the conversion factor relating seconds and years. In other words, what we've determined is by multiplying these four conversion factors together, we have found out that there are 3.1536 times 10 to the 7 seconds in 1 year. So just to recap, notice that the units, minutes, hours, and days were common to both the numerator and the denominator of the fraction. We can treat common units the same way we treat numerical factors that are common to both the numerator and the denominator and cancel them. When common units have been canceled, only the desired units in our conversion factor should remain. So let's practice determining conversion factors. In example 3.8, we are supposed to determine conversion factors that relate the following pairs of units. And in this case, we're going to do this by multiplying together two or more known conversion factors. And we're going to take care to cancel any units that are common to the numerator and the denominator. Let's look at part A. We want to find a conversion factor that relates cubic meters and cubic kilometers. So, in other words, we want to find out how many cubic meters there are in 1 cubic kilometer. So that's our goal, is to be able to write down that fraction. Well, we probably don't know exactly how many cubic meters there are in 1 cubic kilometer, so we're going to start with what we do know. Well, what do we know about meters and kilometers? Remember that the prefix kilo means to multiply by 1,000. That means that there are 1,000 meters in 1 kilometer. So let's write that conversion factor down. We have 1,000 meters in 1 kilometer. Now, we need to be able to relate cubic meters to cubic kilometers. We should be able to do that here by taking our conversion factor that we already have and multiplying it by itself 3 times. So if I take 1,000 meters per 1 kilometer and multiply it by itself 3 times, I arrive at this. So let's look at this. If I multiply these 3 fractions together, notice I get 1,000 cubed in the numerator. 1,000 cubed in the numerator, and also in the numerator I multiply meters by meters by meters. That gives us meters cubed, which is what I was trying to obtain. In the denominator, we will end up with kilometer times kilometer times kilometer, or kilometers cubed, which is what we wanted. Also in the denominator, we'll have 1 times 1 times 1, which of course is 1. So we end up with 1 kilometer cubed. If we cube 1,000, we can either do that on our calculator or we can use our exponent rules. Remember that 1,000 itself is 10 cubed. So 1,000 cubed would be 10 cubed cubed. And this is cubic meters over 1 cubic kilometer. If you take 10 and raise it to the third power and then raise the result to the third power, recall how you can combine the exponents. In a case like this, you multiply the exponents. So you would get 10 to the 9. So we have 10 to the 9 cubic meters per 1 cubic kilometer. Remember that 10 to the 9 is a billion. So really what we learned from this is that there are a billion cubic meters in 1 cubic kilometer. Now let's look at part B. We want to find a conversion factor that relates inches and miles. So again, our goal really is to know how many inches are there in 1 mile. And again, I'm willing to bet that most of us don't know that answer off the top of our heads, so we'll break this into smaller pieces. We know, for instance, that there are 12 inches in 1 foot. We do know that. And we're also told that there are 5,280 feet in 1 mile. So we have 2 conversion factors right here. What would happen if we multiplied them? So let's go ahead and multiply them. Pay attention to the units right away. When you multiply these fractions, you will have inches times feet in the numerator, and in the denominator you're going to have feet times miles. Do you see any units that are common to the numerator and denominator? The answer is yes. Feet is common to the numerator and the denominator. So we can actually cancel the feet units, and that's going to leave us with inches and miles remaining. So when we are finished multiplying these 2 fractions together, we should arrive at a fraction that has this form. So let's go ahead and actually multiply the 12 and the 5,280. When you multiply these together, you end up with 63,360 inches per 1 mile. Okay, let's have a look at Part C. In Part C, we want to find a conversion factor that relates megawatts and kilowatts. Well, recall that mega, the prefix, means to multiply by 10 to the 6. So a megawatt is the same as 10 to the 6th watts, whereas a kilowatt represents 10 to the 3rd, or 1,000 watts. So if you compare these 2 quantities together, this is the bigger quantity right here, and so we can ask, how many kilowatts are there in 1 megawatt? If we are able to say that, then we can write down a conversion factor. We will do this in steps like we did before. Let's use what we know. We know that there are 10 to the 6 watts, and I'm going to abbreviate here, W for watts. There are 10 to the 6 watts in 1 megawatt. We also know that there are 10 to the 3rd watts in 1 kilowatt. So these are 2 conversion factors that we do know. We need to find a conversion factor that relates this unit to this unit. So we ultimately do not need to have the unit of watts present in our conversion factor. We just need these units. So let's try starting with one of the conversion factors. Let's write down 10 to the 6 watts per 1 megawatt. And let's try multiplying this by the reciprocal of our other conversion factor. So I'm going to multiply by 1 kilowatt over 10 to the third watts. Now, why would I multiply by the reciprocal of our conversion factor? Well, let's pay attention to the units here. Notice in the numerator we will be multiplying watts by kilowatts. In the denominator we multiply megawatts by watts. Do you see any units that are common to the numerator and the denominator? You should. You should see that watts is common to both the numerator and the denominator, and therefore is eligible for canceling. What's left are kilowatts in the numerator and megawatts in the denominator. So when we are done simplifying this product, we will have kilowatts in the numerator, megawatts in the denominator, and we'll be able to say how many kilowatts there are in a megawatt. So we will have found the conversion factor for these units. So let's go ahead and finish this. If we multiply out the numerator, we get 10 to the 6 kilowatts, and in the denominator we get 10 to the third megawatts. Using our exponent properties, if we have 10 to the 6 divided by 10 to the third, we know we should be subtracting our exponents. So this simplifies down to 10 to the third kilowatts divided by 1 megawatt. So in other words, there are 1,000 kilowatts in 1 megawatt.